So I'm going to get straight into it. So today I kind of want to put two questions to you really for this talk. And firstly, what are the effects of sediment density flows combined with pre-transport decay on the preservation potential of soft-bodied organisms? And most importantly, what effect does this have and how does this relate to the Burgess Shale? So in order to try and attempt to answer these questions, the first thing we need to do is we went out and we collected sedimentological samples from the Buatois quarry and we analysed the sedimentological data. And what we find is these structures here. So we have these shelly debris fragmented layers, we have large quartz grains along these beds, we have erosional bases with micro scours, and again this is also seen throughout the millimetre thin section logging that I undertook. And what I did with this is that you find two different types of deposits in the Burgess Shale, and what you can do with these is you can relate your deposit type to flow type. And what we find is that the Burgess Shale, the Buatois quarry, is you have something between an upward transitional plug flow and a quasi-laminar plug flow. So we can do some nice fancy sedimentological analysis then on this, and we can come up with the yield strength to figure out the speed of one of these types of flows, the cohesiveness, and then the concentration of clay in one of these flows. So that's what we did, and what we find is you have something that's going at about 0.4 meters per second and something with about 11% kaolinite clay. Now there is a reason why that's upside down. So for this we produced a Burgess Shale flow type in the lab. So you can see from that it's quite a laminar transitional flow. It probably has a more kind of turbulent base. It's not really going that fast. It's actually quite not that exciting. But in terms of the variables we investigated pre-transport decay from 0, 24 and 48 hours on a polychaete elite of virons. And we also looked at an independent variable of transport duration of 25 minutes, 225 minutes and 900 minutes, which is equivalent of about 21.6 kilometers. And in order to quantify then the damage that you see on these polychaetes after that, is I came up with an index of overall completeness. So you have state 1, which is undamaged, a pristine polychaete, right down to number 4, where the only thing that you're finding is the jaws and the chaetae, which I can tell you are extremely difficult to find in a flume tank. So what are the results? What did we observe? So what we find is after 25 minutes of flow duration, at 0 hours we get a pristine polychaete, 24 hours, again pristine, and after 48 hours of pre-transport decay, you get state 2, which is you still have a polychaete, but it's a very damaged posterior. So after 225 minutes in a flow duration, at 0 hours, so no pre-transport decay, totally fine. 24 hours, again, we still have a polychaete, quite incredibly. And after 48 hours, we're just getting some of the remains, and again, just some of the jaws. So 900 minutes of flow duration, again, over 20 kilometers of transport. You're getting at 0 hour decay, a polychaete, 24 hours decay, and absolutely amazingly, we still have a polychaete, 48 hour pre-transport decay, and further 20 kilometers of transport. So what does that mean? So we performed statistical analysis and post hoc tests, and we found that pre-transport decay does have a statistically significant effect on the damage you're seeing to your polychaete. So the longer that it's been decayed before it goes into transport, the overall quality of the polychaete will decrease. But really interestingly is there's no significant effect of further transport duration. So that's to say that there is no additional effect of transport after the damage you see from decay. So what does that mean for the Burgess Shale? Well, when we compare these states in the Burgess Shale, you can find 3 different states, so there's no jaws in the Burgess Shale. So you have state 1 where it's perfectly preserved, state 2 there's damage here in the posterior region, and state 3 where you're just getting some sort of organic polychaete remains. And in the specimens that I looked at in the ROM, we find with Burgess chaeta and Canadia that predominantly the Burgess Shale fossils are at state 1, which is meaning that these animals are being brought in, transported in by a flow, but are very recently deceased. and then being entombed by another sediment-laden flow coming in and rapidly entombing the specimen. So the conclusions. So the Burgess Shale is in these upper transitional to quasi-laminar plug flows. Soft body organisms, even after pre-transport decay, can endure transport at substantial distances. However, your pre-transport decay, depending on how long it's, how the level of it, how further it's progressed, that will damage the quality of the fossil. So when you compare my extinct specimens to extant, they indicate that these were recently deceased. And then on top of this, the Burgess Shale biota could have been transported very significant distances. And this really does have implications when we're reconstructing the paleoecology for places like Lagerstadt, like the Burgess Shale, that are in flow deposits, and how we reconstruct these as life communities. So I just want to say thank you to my supervisors and for the number of people that helped me on this project. Thank you.
Thank you. We've got time for questions.